right, so I'm going to do one more with fractions and one with decimals before I move on to the next section. Okay, so when we're looking at this one, we have more fractions. 1/2 x plus 1/3 y is 8/3, and 1/3 x minus 3/5 y is 10. I'm going to clean this whole mess up. I'm going to get a common denominator and multiply it through, because if I can get away without using fractions, I always will. I love fractions, but I like to clean them up and make them work for me. Okay, so I'm going to multiply this first equation by its least common denominator, which is 6, because both 2 and 3 go into 6. And when I do, I get 6 over 2 is 3x. And then when I multiply the 6 times the 1/3, I get a 2y. And then when I multiply the 6 times the 8/3, I get a 16. So then I'm going to multiply the other equation by its least common denominator, which I have a 3 times a 5 is 15. So I'm going to multiply the second equation by 15 to get another equation that has no fractions. So 15 times 1/3 is 5x, and 15 times a negative 3/5 is going to be negative 9y, and 15 times 10 is 150. Remember, when you multiply by 10, you just add another 0 on the end, and you get your answer. So now I have two equations without fractions, but they're not ready to eliminate. So what I'm going to do is I'm going to try to eliminate my x's. And so I'm going to multiply to get a multiple that both 3 and 5 share. The least common multiple is 15. So I want to get to a 15 and a negative 15. So if I'm trying to get to 15 from a 3, I have to multiply by 5. If I want to get to a 15 from a 5, I have to multiply by a 3, but I want them to be opposite, so I'm going to multiply by a negative 3. Okay, so now I've got 15x and 10y distributing through. 5 times 2 is 10y. 5 times 16 is 80. So this will be my new first equation. And my second one will be negative 3 times a 5x, and a negative 3 times a 9y, and a negative 3 times a 150. So this is my new equation down here, the second one down here when I multiply those all together. Now, notice I've got a 15x and a negative 15x. So when I add these two together, and I can do that because of the addition property of equality, add two sides of the equation together, then I'm going to get my x's eliminate. 10 plus 27 is 37y right here. And 80 minus a 450 is negative 370. But to get my y by itself, I need to divide by 37 on both sides. And I get y is negative 370 divided by 37. I think I erased that a little bit. Negative 370 divided by 37, which is negative 10. So y is negative 10, and we'll come back and finish. So this one was my second equation, my second original equation. So we're going to plug in a negative 10 right here for the y. So when we do that, a negative 10 right there in there for the y, then we're going to get a 1/3 x plus, because we have a minus times a minus, the 10 and the 5 will cancel, and we'll get a plus 6 equals 10. Okay, so we end up with 1/3 x equaling, when I subtract 6 from both sides, I get a 4. 1/3 x is 4. If I multiply both sides by 3, I get x is 12. And with my y is negative 10, I have my solution. So now I'm going to put both of those back into the other equation. Okay, so we just used here the second equation of the two. Okay, so now we're going to go back and I'm going to recopy the first equation, 1/2 x plus 1/3 y is 8/3, and I'm going to substitute in a y is -10 and an x is 12 into the first equation, the one that we didn't just use. And now I've got 1/2 of 12, and 1/2 of 12 is 6, and 1/3 of -10 is just -10/3, is equal to 8/3. Well, can we write 6 as a certain number of thirds? And the answer is yes. So 6 is 18/3 minus 10/3 is 8/3. And it's true. Therefore, this is my solution set of the equation. So to summarize, what did I do? Okay, when I was working with fractions, I first wanted to get rid of those horrible fractions. So I multiplied both equations by the least common denominator in that equation. Then I had two equations that didn't have fractions in them, but that I still had to get a common coefficient in front of one of my terms, either x or y variables. Okay, in this problem, I chose to get my x's the same. So after I multiplied to get my x's the same, then I added the two equations to eliminate the x's so that I could solve for the y. And then I went back into one of the equations and I substituted in the y to get the x. And then I went into the other equation and substituted both to check. So now we're coming back with a decimal problem, and then we will move on to something else. All right, so decimals often scare people away, but this problem is very, very simple, because just like the fractions we're going to multiply by a least common denominator, decimals are even easier, because we know that we're going to multiply by a multiple of 10 or a power of 10. We're going to multiply by a power of 10. So this one has one decimal, one decimal, one decimal, one decimal, one decimal place, one decimal. Okay, all of them would be cleared out if we just multiplied both equations by 10. And that's what we're going to do. Remember, when we multiply by 10, we move one decimal place to the right. So one decimal place to the right, one decimal place to the right, one decimal place to the right, one decimal place. I'm multiplying both equations by 10, and now I have 3x minus 2y is 18, and 4x plus 5y is 1. Oh, so much easier to look at. No decimals, okay? So clear out your decimals just like you want to clear out your fractions. Now, this one's not very pretty, but I'm going to do it a little differently. I'm going to go for the y's this time, because I already have one positive y and one negative y, so I already have opposite signs. I'm going to multiply both equations to get to a negative 10y and a 10y, so that my y's will eliminate. So in order to get this first one to a negative 10, I need to multiply by 5 all the way across. And then to multiply this, get the second one to a 10y, I need to multiply by 2 all the way across. I'm multiplying each equation by what I need it to be multiplied by. So now this first equation, I'm going to multiply the 5. 5 times 3x is 15x. 5 times a negative 2y is a negative 10y. 5 times an 18 is 90. Okay? So now I'm going to multiply the 2 all the way across the bottom equation. So 2 times 4x is 8x. 2 times 5y is 10y. And 2 times 1 is 2. I'm ready to eliminate those y's. So when I add these two equations together, I'm going to get a 23x. My y's are going to cancel. Is 92. Okay? And 92 divided by 23 is exactly 4. I had to do it out. Okay? So x is 4. So now I'm going to go back into one of my two equations and plug in x is 4. So I'm going to use my already simplified equation. So let's use 3x minus 2y is 18, which was the top of our two equations. Okay, so 3x minus 2y is 18. I'm going to substitute in my x is 4 right here to get my y. So I wind up with 12 minus 2y is 18. If I take away 12 and take away 12, I get minus 2y is 6, or y is negative 3. Okay, so I'm going to put y is negative 3 up there. So I have my points here. And now I'm going to take those two values and put them into the other equation. I used the 3x minus 2y is 18 just now, so I'm going to use the other one, 4x plus 5y is 1. Okay, so 4x plus 5y is 1. Take the other equation and plug in both values to check. So my x is 4, so I'm going to plug in a 4. My y is a negative 3. I plug that in there, and I get a 16 minus a 15 is 1. And that is true, telling me that I got it right and I did the problem correctly. And now we're going to move on to some of those special cases. Okay, we've done substitution, we've done elimination, we've talked about fractions and decimals. So now we're going to move into some of those special cases. Remember, at the beginning of this section, we were talking about we had 3 different cases. Okay, we can have one solution. Everything we've talked about today so far, all of 5.1 has been one solution. But now we're going to talk about how do you recognize problems that have no solution, or those that are actually the same line. That was sloppy. Okay, actually the same line. So that's what we're going to come back and do in the next section, the last part of 5.1. 5.1 is kind of long and tedious. So this is Mrs. A. May God bless your day.